For thousands of years, the world has argued about who the ancient Egyptians really were. Every civilization that came after claimed them. Greeks said they were Proto-Europeans. Pan-Africanists argued they were Black Africans. Arab scholars placed their origins in the ancient Near East. Everyone had a theory, everyone had an agenda. The debate never produced a winner because it was never really about evidence, it was about ownership. Then, in a laboratory at Liverpool John Moores University, scientists extracted DNA from a sealed clay pot buried 4,500 years ago in a village 265 kilometers south of Cairo. They compared that genome to thousands of living and ancient populations from every corner of the planet. What they found did not confirm any of the competing narratives. It dismantled all of them. The answer had been sitting in the ground the entire time, written in the bones of a man nobody had ever heard of. In 1902, a team of archaeologists working under British explorer John Garstang was moving through the sands of New Wairat, a small village sitting 265 kilometers south of Cairo near the ancient necropolis of Beni Hassan. They were not expecting anything remarkable. The site was not Luxor. It was not the Valley of the Kings. It was a stretch of dry ground that history had largely ignored, the kind of place excavators passed through on the way to somewhere more impressive. Then they found the pot. It was a sealed clay vessel, unremarkable in appearance, the sort of container that would have sat in any Egyptian household without drawing a second glance. But when archaeologists opened it, they found a human skeleton curled inside in a fetal position, arms drawn in, knees pulled toward the chest, as though the man had simply folded himself into sleep and never woken. Radiocarbon dating would later confirm he had been lying there for somewhere between 4,500 and 4,800 years. He had been placed in that pot during Egypt's early Old Kingdom, the same era in which the Great Pyramid of Khufu was either rising from the plateau at Giza or had only just been completed. While one of the most ambitious construction projects in human history was reshaping the skyline, this man was living out his days in a village beside the Nile and asking nothing of posterity. He was not a pharaoh. He was not a priest or a general or a nobleman whose name had been carved into temple walls. He was a commoner, the kind of person ancient history almost never preserves, the kind of person the historical record treats as scenery rather than subject. No inscription accompanied his burial. No papyrus recorded his name. He left behind no monument, no legacy, no written trace of any kind. What he left behind was his skeleton, sealed inside a clay pot inside a rock-cut tomb overlooking the Nile, and that turned out to be enough. For decades, scientists had been trying to read the genetic history of ancient Egypt and failing. The problem was mummification. From the 1980s onward, geneticists attempted to extract usable DNA from Egyptian mummies and found the process essentially impossible. The chemicals used in embalming, natron salts, resins, and the various preserving agents that kept flesh intact for the afterlife were catastrophic for genetic material. They preserved the body, but destroyed the molecular record inside it. What mummification gave with one hand, it took away with the other. The DNA that might have answered centuries of questions had been chemically erased by the very process designed to cheat death. 2017 study managed to partially sequence DNA from 90 mummies dating between 1380 BC and 425 BC, a significant achievement, but the results were incomplete. The coverage was too thin, the degradation too extensive to build a full genetic picture. Researchers had fragments, not answers. The oldest and most formative period of Egyptian civilization, the era of pyramid building, the era when the foundational identity of this culture was being established, remained genetically invisible. Nobody had managed to reach back that far and read what was written there. The man from New Wairat changed that entirely. His survival was a matter of luck, timing, and burial practice combined. He had not been embalmed. Mummification was not yet common practice during the early Old Kingdom, which meant his body had been spared the chemical destruction that had erased so many others. Instead, he had been sealed inside a pottery vessel and placed within a rock-cut tomb, a combination that shielded him from the harsh, desiccating Egyptian climate that would otherwise have reduced his remains to dust. The tomb acted as a barrier, the pot acted as a sealed chamber, and inside that chamber, his DNA waited. Researchers from Liverpool John Moores University and the University of Aberdeen extracted genetic material from the cementum of his tooth, the hard bone-like tissue that anchors teeth to the jaw and is among the most reliable sources of preserved DNA in ancient remains. They sequenced his genome to 2.02 times coverage, meaning the entire genetic sequence was read twice over to ensure accuracy and eliminate errors. What they recovered was the oldest complete genome ever extracted from an ancient Egyptian. Not a fragment, not a partial result. A full genetic portrait of a man who had lived and worked and died beside the Nile 4,500 years ago, at the very moment the civilization he was part of was building its most enduring monuments. His name is lost. His story is not. The genome was intact. Now came the question every researcher in the room already knew was the most dangerous one to answer. Who was he, and where did his people come from? To find out, scientists ran his DNA through two of the most powerful analytical tools available in modern population genetics. The first was principal component analysis, a method that plots genetic similarities across populations on a graph, effectively producing a map of ancestry where the closer two populations appear, the more closely related they are. The second was admixture clustering, which breaks overall ancestry down into proportional components, identifying what percentage of a person's genome traces to which ancient population. Think of it as a detailed breakdown of a family tree reaching back not generations, but millennia. Together, these tools allowed researchers to compare the Nuweirat man's genome against a pool of over 3,000 modern individuals and 800 ancient ones, drawn from populations across the entire planet. Every major genetic cluster on Earth was represented. There was nowhere for the results to hide. The first findings stopped the team. Approximately 77.6% of his ancestry traced back to Middle Neolithic North Africans, populations genetically similar to those identified at Morocco's Skirat Roazi archaeological site. These were the indigenous people of the Nile Valley, the descendants of early farmers who had been working this landscape for thousands of years before the first dynasty was established. They grew wheat and barley along the river's fertile banks, tamed the annual floods, built the agricultural foundations upon which Egyptian civilization would eventually rise. They were not migrants or conquerors. They were the original population of this corridor of land, and they made up the overwhelming majority of this one man's ancestry. That result, on its own, would have been significant. It was the second finding that made the study impossible to ignore. 22.4% of his genome traced to Neolithic Mesopotamia, not medieval Mesopotamia, not the Mesopotamia of Babylonian kings or Assyrian armies. Neolithic Mesopotamia, dating to between 9,000 and 8,000 BC, the region corresponding to modern-day Iraq, Iran, and parts of Syria and Jordan. A further 1.1 to 4.7% pointed to Levantine ancestry from the Eastern Mediterranean, encompassing modern Syria, Lebanon, and Jordan. These were not traces. They were not noise in the data. They were a structural component of who this man was, woven into his genome at a level that could only mean one thing. Somewhere in his ancestry, generations before he was born, people from the Fertile Crescent had entered the Nile Valley and stayed. This matters because of what the Fertile Crescent represents in human history. It is not an arbitrary geographical label. Around 10,000 BC, in that arc of land stretching from the eastern Mediterranean coast through modern Iraq and Iran, human beings first domesticated plants and animals. The Neolithic Revolution began there, farming began there, the social structures that made cities and civilizations possible began there. For this reason, it is often described as the cradle of civilization, a phrase that gets used so frequently it has lost some of its weight. What it actually means is that the way most of the world eventually learned to live can be traced back to a specific group of people in a specific region at a specific moment in time. And a measurable portion of that same ancestry was sitting inside an Egyptian commoner buried in a clay pot in the early Old Kingdom. The Mesopotamian component was not recent. It was not the result of trade contacts or diplomatic exchanges during the Pyramid Age. The genetic signal was ancient, deep, and diffuse in the way that only happens when migration occurred many generations earlier and the incoming ancestry spread quietly through a population over centuries. By the time this man was alive, the Mesopotamian contribution to his lineage was already old history. His community had absorbed it long before anyone living in his era would have had any memory of it arriving. What this produced was something none of the competing narratives about ancient Egyptian identity had ever accounted for. Ancient Egypt was not an isolated African civilization sealed off from the outside world. It was not a Near Eastern colony transplanted onto the Nile. It was a genuine convergence, a population that had developed from indigenous North African roots while absorbing, over vast stretches of prehistoric time, influences and people from one of the most consequential regions in human history. The modern world had spent centuries arguing about which box to put ancient Egypt in. The DNA suggested the box never existed. The ancestry breakdown raised an immediate question, and it was the kind of question that sounds simple until you try to answer it. If over 3/4 of his genome traced to North African populations, and if both his maternal and paternal lineages pointed to the same regional origin, then where exactly was the Mesopotamian ancestry coming from? How does a man whose direct family lines are North African carry a fifth of his genome from a region thousands of kilometers away? The answer lies in understanding what genetic lineage testing actually measures, and more importantly, what it does not. Scientists examined 2 specific types of DNA to trace his direct ancestral lines. The first was mitochondrial DNA, which is passed exclusively from mothers to their children, generation after generation, without mixing with the father's contribution. It traces one unbroken line back through time, always maternal, always singular. His mitochondrial DNA belonged to haplogroup N1A1B2, a genetic branch found commonly across North Africa and West Asia, consistent with a population that had been living in this corridor of land for thousands of years. The second was his Y chromosome, which passes exclusively from fathers to sons in an equally unbroken paternal line. His Y chromosome belonged to haplogroup E1B1B, one of the most widespread lineages across North Africa and the broader region, deeply rooted in the populations that had inhabited this landscape since the Neolithic period. Both lines, maternal and paternal, told the same story. His direct ancestors, as far back as these markers could reach, were North African. So how does Mesopotamia appear in his genome at all? This is where most people's intuition about ancestry breaks down, and where the science becomes genuinely illuminating rather than simply confirmatory. Haplogroups trace only 2 lines out of an almost incomprehensible number of ancestral connections. Your mitochondrial DNA follows your mother, then her mother, then her mother's mother, stretching back in one single unbroken thread. Your Y chromosome follows your father, then his father, then his father's father, equally singular and equally narrow. But a human being does not have 2 ancestors. They have 2 parents, 4 grandparents, 8 great-grandparents, 16 great-great-grandparents, and the number doubles with every generation. Go back 30 generations, and the theoretical number of distinct ancestors runs into the billions. Haplogroups capture exactly 2 of those lines. The rest of the family tree, the vast majority of it, is recorded not in mitochondrial DNA or the Y chromosome, but in autosomal DNA, the genetic material inherited from all branches of the family simultaneously. His autosomal DNA told the fuller story. It was there, in the combined inheritance from every branch of his ancestry, that the Mesopotamian component appeared. Somewhere in his family tree, not along the direct maternal or paternal lines that haplogroups trace, but through the dozens of other ancestral pathways that autosomal DNA captures, people from the Fertile Crescent had entered his lineage. They had mixed with the North African population of the Nile Valley. Their descendants had mixed further. And by the time this man was alive, that Mesopotamian ancestry had dispersed through his genome as a diffuse but measurable signal, invisible to haplogroup analysis but clearly legible to the broader autosomal picture. This is not a contradiction. It is a demonstration of how complex real human ancestry actually is, and how inadequate any single metric is for capturing it. The two tools, haplogroups and autosomal analysis, are not in disagreement. They are measuring different things. One traces the direct line, the other reads the whole tree. There was one further detail in his genome that deserves attention. Scientists found no significant long runs of homozygosity in his DNA. These are stretches of identical genetic sequences that appear when two closely related individuals have children together, the genetic consequence of a closed or isolated community where relatives intermarry over generations. Their absence in his genome was meaningful. It indicated that his parents were not closely related, that his community was not genetically isolated, that people in the Nile Valley during the early Old Kingdom were mixing with individuals from outside their immediate group. His genome was the product of an open population, one connected to a wider world through movement, trade, and intermarriage, stretching back across prehistoric time. His direct lineage was North African. His community's history reached far beyond North Africa. Both things were true simultaneously, and neither one canceled the other out. That tension between the simple story a single ancestral line tells and the complicated reality that the full genome reveals is precisely what makes ancient DNA so much more unsettling than the narratives built without it. The genome answered the question of where his people came from. His bones answered a different question entirely. They answered the question of how he actually lived. Isotope analysis is a technique that reads chemical signatures preserved in skeletal remains, signatures that accumulate during life from the food a person ate, the water they drank, and the soil their environment was built on. Different regions leave different chemical fingerprints, and those fingerprints do not lie. When researchers applied isotope analysis to his remains, the results were unambiguous. Oxygen isotopes in his bones matched the water sources of the Nile Valley precisely. Strontium ratios aligned with the geology of the Egyptian landscape. He was not a migrant who had arrived from elsewhere. He was not a trader who had spent years moving between regions. He was born here, grew up here, and spent his entire life within the boundaries of the world the Nile defined. Whatever Mesopotamian ancestry ran through his genome had arrived in his family line long before he drew his first breath. His diet, reconstructed from carbon and nitrogen isotopes, was exactly what you would expect from an early Old Kingdom Egyptian farmer. Wheat and barley formed the staple base. Animal protein appeared regularly, suggesting livestock rather than pure subsistence farming. There were possible traces of Nile fish, or crops, grown in fields fertilized with manure, consistent with the agricultural practices developing along the river during this period. He ate what his land produced and what his community raised. Nothing in his diet suggested wealth or privilege. Gauge. Nothing suggested deprivation either. He was a man sustained by the ordinary provisions of a working life. His physical profile emerged from the skeletal measurements with similar clarity. He stood between 157 and 160.5 centimeters tall, roughly 5 feet 2 inches, consistent with average male stature in ancient Egypt during this period. He lived to somewhere between 44 and 64 years of age, with analysis suggesting the upper end of that range was more likely. In a world without modern medicine, without antibiotics, without surgical intervention, reaching 60 was an achievement measured not in luck alone, but in constitution. Translated into contemporary terms, it was the rough equivalent of reaching your 80s today. Genetic analysis predicted brown eyes and brown to black hair, consistent with the broader North African and Near Eastern populations his ancestry reflected. A facial reconstruction was produced using three-dimensional scans generated by an RTX space spider scanner, a precision imaging tool that captured the geometry of his skull in fine detail. The resulting image was rendered in black and white. The decision was deliberate. Uncertainty about his precise skin tone and exact hair shade made confident colorization scientifically irresponsible, and the researchers chose accuracy over the visual impact a color reconstruction would have produced. What emerged from the scanner was the weathered face of a man who had spent decades doing physical work under an unforgiving sun. His skeleton confirmed every inference that face suggested. The bone record was a ledger of accumulated damage, the kind that only decades of sustained physical labor produce. Severe osteoarthritis had developed across multiple joints and along the vertebrae, with particular concentration in the cervical spine, the region of the neck and upper back that bears the load of whatever the arms are doing for hours at a time. Muscle attachment marks on the bone surfaces told their own story. His arms had been extended for long periods. He had carried heavy loads repeatedly and consistently enough that the effort had left permanent impressions on the architecture of his skeleton. His pelvic sitting bones had enlarged, a physiological adaptation to long hours spent on hard surfaces. His spine had curved forward from sustained leaning. His right foot showed arthritis from repetitive mechanical stress applied in the same direction over and over again. Taken together, these markers pointed toward a specific occupation with unusual precision: pottery making. The posture required to work a slow-turning pottery wheel, arms extended, body leaning forward, weight shifting through one foot repeatedly while seated on a hard surface, matches his skeletal damage in almost every detail. The slow-turning pottery wheel had been introduced into Egypt around 2400 BC, arriving most likely through Mesopotamian or Levantine trade routes that bypassed the Sinai and reached the Nile Valley through networks of exchange that had been operating for millennia. He worked himself into the earth one pot at a time. He did it for decades. And when he died, the community that had watched him work decided he deserved something more than an unmarked grave. The burial did not fit the man the evidence described. Everything recovered from his skeleton pointed toward a working life of relentless physical labor. His joints were worn. His spine was curved. His bones carried the accumulated damage of decades spent bent over a pottery wheel, lifting heavy loads, sitting on hard surfaces until the effort had reshaped him at a structural level. By every physical measure, this was a man who worked with his hands from youth to old age, the kind of person ancient societies depended upon absolutely and recorded almost never. Commoners of his era did not receive elaborate burials. They were placed in shallow graves in the desert sand, wrapped in linen if their families could afford it, marked with nothing if they could not. The earth received them and closed over them, and that was the end of it. This man was different. He had been placed inside a sealed ceramic vessel, carefully positioned in a fetal posture and interred within a rock-cut tomb overlooking the Nile. These were not the burial arrangements of a forgotten laborer. Rock-cut tombs required significant effort and resources to construct. They had to be carved directly into the bedrock, a process that demanded skilled labor, time, and some degree of social organization behind it. During the 3rd and 4th dynasties, this type of burial was typically associated with individuals of elevated status, administrators, skilled specialists, people whose communities considered them worth the additional investment that a proper tomb represented. Pot burials within such tombs, while not unheard of, added another layer of deliberate care. Someone had chosen this vessel, positioned this body, sealed this container, and placed it in a location with a view of the river. None of that happened by accident. None of it was cheap. The contradiction sits at the center of his story and resists easy resolution. A man whose body bore the marks of a craftsman, buried with the consideration typically reserved for someone of consequence. How do you account for that gap? One possibility is status through specialization. The Old Kingdom was not a society that treated all manual labor equally. Skilled craftsmen occupied a different position in the social hierarchy than unskilled laborers, and pottery during this period was not a marginal trade. The pyramid construction projects at Giza and elsewhere required enormous quantities of ceramic goods. Storage jars held grain, water, and oil for the thousands of workers engaged in construction. Tools were transported and stored in ceramic containers. Ritual objects were produced in the same workshops that supplied everyday vessels. A master potter serving the logistical needs of one of the largest construction operations in human history would have been a figure of genuine practical importance, the kind of person whose death a community might mark with more than a shallow grave in the sand. There is a second possibility, and it connects directly to the Mesopotamian ancestry running through his genome. The slow-turning pottery wheel he almost certainly used was not an Egyptian invention. It arrived in Egypt from outside, most likely carried along the same trade networks that had been connecting the Nile Valley to the Fertile Crescent for thousands of years, routes that bypassed the Sinai and moved goods, ideas, and people across the ancient Near East in patterns that predate written history. A craftsman who worked with imported technology, who perhaps maintained relationships with the Mesopotamian or Levantine merchants who moved along those routes, who traded finished ceramic goods for materials or wealth that his community could not produce locally, would have occupied a position that combined practical skill with commercial connection. That combination, in any ancient society, tends to generate both income and trade influence. Perhaps he was both things simultaneously. A man who worked like a laborer and lived like a specialist. A craftsman whose hands built the vessels that fed pyramid workers, and whose ancestry and trade connections stretched back through centuries of contact with the civilizations that had first developed the technology he used every day. His burial may not contradict his working life at all. It may simply reflect a status that his physical remains, read in isolation, cannot fully convey. What is certain is that someone cared. Someone chose the vessel. Someone carved the tomb. Someone positioned his body with deliberation, oriented it toward a river that had sustained his people for thousands of years, and sealed him inside with enough care that 4,500 years later, a team of scientists could open that vessel and read everything he had been. That act of burial was itself a record. It said that this man mattered. The DNA confirmed the rest. The man from New Wayrat was one person. But what his genome revealed was not a story about one person. It was a story about connectivity, about the invisible threads of movement and exchange that ran beneath the surface of ancient civilizations long before anyone thought to write them down. And it forced a fundamental reassessment of something historians had been debating, and in many cases fighting over, for the better part of 2 centuries. Egypt had not developed in isolation. This was not a new suggestion. Archaeologists had been accumulating evidence of contact between the Nile Valley and the Fertile Crescent for decades. Trade goods moved between these regions from at least 6,000 BC. Domesticated plants arrived in Egypt from the Near East. Domesticated animals followed. By 4000 BC, Mesopotamian artistic and cultural influences were visible in the Egyptian archaeological record, appearing in pottery styles, in cylinder seals, in architectural motifs that carried the fingerprints of a civilization located thousands of kilometers to the east. The connections were real, and they were old. But connections between objects and connections between people are different things. And until now, the genetic evidence to confirm that actual human beings had been moving along these routes during the prehistoric and pre-dynastic periods simply did not exist. The New Wayrat man provided it. His genome was the first direct genetic proof that migration, not just trade, was occurring between Mesopotamia and the Nile Valley during the Neolithic and pre-dynastic periods. People had walked those routes. They had settled. They had married into local communities, and their descendants had carried the genetic signal of that movement forward through generations until it appeared, diluted but readable, in the genome of a potter buried in a clay vessel during the age of the pyramids. The objects had always suggested this. The DNA confirmed it. This reframes the origin of Egyptian civilization in ways that neither its admirers nor its claimants had anticipated. For generations, the debate over ancient Egyptian identity had been conducted largely as a territorial argument. Different groups, each with their own historical and political reasons for the claim, positioned ancient Egypt as belonging to their ancestral tradition. The civilization was too significant, too visible, too persistently astonishing to be left without an owner. What the genetics reveals is that the premise of that argument was always wrong. Ancient Egypt was not a pure expression of any single population's heritage. It was a convergence built at the intersection of indigenous North African development and deep prehistoric contact with some of the most consequential populations in human history. It belonged in the genetic sense to both and to neither exclusively. This pattern is not unique to Egypt. It mirrors findings that have emerged from ancient DNA studies conducted across the world over the past decade. The story of the English, whose ancestry was long framed around successive waves of Germanic and Scandinavian invasion, turned out to be far more continuous and far more indigenous than the historical record had suggested. Elite conquest narratives, whether Anglo-Saxon, Viking, or Norman, consistently overstated the degree to which incoming groups replaced existing populations. The written record exaggerated displacement because displacement legitimized power. The genetics revealed continuity because continuity was the actual experience of the people living through those events. Egypt fits the same template. The ancient historians and later scholars who described its origins in terms that served their own civilizational claims were doing what victors and inheritors always do. They were writing a story that placed themselves at the center of it. DNA keeps a different kind of record. It does not care about political utility. It does not respond to the needs of national identity or the arguments of competing scholarly traditions. It simply preserves what happened, encoded in molecules that survive millennia inside sealed pots and rock-cut tombs, waiting for the technology to arrive that can finally read them. And the reading is only beginning. Scientists working in this field have stated that the Nuweirat man represents a proof of concept as much as a discovery in himself. His genome demonstrated that complete ancient Egyptian DNA from the Old Kingdom period can be recovered and sequenced. More tombs exist, more sealed vessels are waiting, more forgotten commoners, men and women whose names were never recorded but whose bones carry the full complexity of a civilization the world has never stopped arguing about, are lying in the ground along the Nile. Each one is a data point. Each one is a witness. And each one, when the science finally reaches them, will add another layer to a story that is turning out to be far older, far more connected, and far more human than any single origin myth was ever capable of containing. Return to the clay pot. A man curled inside it, unnamed, unrecorded, forgotten for 4,500 years beneath the Egyptian sand. No inscription marked his life. No monument carried his memory forward, and yet his bones have answered questions that centuries of scholarship could not resolve. He was North African in his direct bloodline and Mesopotamian in his deeper ancestry. He was a craftsman who worked until his skeleton bore the proof of it. He was buried with a care that said he mattered to the people who knew him. And now scientists say this is only the beginning. More genomes are coming, more sealed tombs, more unnamed commoners, more ordinary people who kept no records but left everything written in their bones. The story of ancient Egypt does not belong to any nation or identity movement. It belongs to the evidence. And the evidence, as it always does, turns out to be stranger and richer than anything we were told.